X gon' give it to you. Fuck, wait for you to get it on your own. X gon' deliver to you. Knock, knock, open up.
What's up, nerds? Welcome back to Tea Time with your favorite software engineer. Today I'm going to be going over some root to leaf numbers, but first I want to tell you guys about a LeetCode competition I'm hosting in my Slack channel. The description is below. If you guys join, there's a cash prize. If 5 more people join this month, then next month the cash prize will be $20. So make sure you guys do that. It's easy. We have a spreadsheet here. Show you. We keep track of our scores. So we've already done 2 months. So winner gets the cash prize at the end of the month. So make sure you guys join that and subscribe to the channel. I'm trying to grow the channel 10 subscribers a day. Almost there. Anyways, the description reads, given a binary tree containing digits from 0 to 9 only, each root to leaf path could represent a number. So 1, 2, 3 would represent 123. Find the total sum of all root to leaf numbers. A leaf is a node of no trend, obviously. So on my whiteboard, I have this example written out. So I didn't like this example. It's too small. So we have 495, 495, then we have 491, and then 40. So we add all those up to get 1026. So let's go to the whiteboard. We know we're going to need a total sum variable. So total sum, and we're going to initialize it to 0. And then we got to think how we want to traverse the tree. So I think doing it recursively is easier. So DFS, and then we got to think of which way we want to do it. So do we want to do a pre-order, post-order? So for this one, I am going to do pre-order. I just think it's easier. We just go left. I mean, we could go right, but I'm going to do it left in this example. So we're going to want to have a function called, you want to call it exactly what one of the guys in my Slack channel actually told me this, that you want to say which way you're doing the depth first search. So pre-order, we're going to call it pre-order, and we're going to want to pass in, I believe it's just tree node. Yeah, it's tree node root, and int sum. So this is basically our helper function. We're going to have our main function. I believe it's called sum numbers. So this is, I just went backwards. So sum numbers is our main function. And we're just going to want to call pre-order in our sum number, our main function. So it's just passing in root. And all we're going to do is call pre-order root and pass in 0 because the sum's going to start off as 0. So we're going to have a global total sum and then a sum for each recursive stack, basically. And finally, we're just going to return total sum. So now let's write out our pre-order function. So how do we want to do this? We just said we're going to do pre-order, so we're going to do root.left. But first we want to, if root is null, then we know that we've reached the end of that stack, the path, basically. So if root equals null, we're just going to return. And that is sloppy, but let's keep going. So the next thing we want to do is if root.left, so if root.left is null, equals null. So if both children are null, then we know we're at the end of the path and we want to add it to total sum. So, and root.right equals null. Then we're going to total sum, add it to, we're going to add plus equals, I didn't mean to do minus, plus equals sum, and we're going to break out of that because we want to kick back out of the recursive stack and go back to where we were in the pre-order. And then we just want to call pre-order root.left because we're doing pre-order. We go left first. and we're going to pass it sum. So sum, we also forgot to, no, sum is initialized in the parameter, sorry. And then we want to do pre-order root dot right. So that's basically this whole problem. So basically all these tree problems, you're going to want to do either BFS or DFS, or you can do it iteratively. Well, actually BFS is iteratively, but if we're doing DFS, we want to figure out if we're doing pre-order or post-order. I just chose post or pre-order. I think it's easier to always go, my mind just works easier left first. So what this is doing is we're going to start here. We're going to add, well, actually, I skipped the part where we add sum. So let's just code this out first, because I skipped the part where we add sum. And I'm kind of blocking the code in the whiteboard anyways. So, oh no, this is our main function. So pre-order root and 0, and then we're just going to return total sum. And now let's write our helper function. So public void pre-order tree node root and int sum. So if root is null, that's where we're going to want to kick back out of the recursive stack and go down the other possible paths. And then if I believe we want to, if root dot left equals null and root dot equals null, so that means we're at the end of the path. Basically we're at the leaf. Then we're going to add it to total sum. We're going to add the sum to total sum plus equals sum. And we also, since if root isn't null, we want to add the sum, the node value to sum. So sum equals sum. So we can't just add it because we're adding it in, like, we're it's like we're seeing it as a string. We're just not adding 4 plus 9. We're doing 40. Well, we're doing 4 and then we add a 9 to the end. So we have to multiply sum by 10 and then add root dot val. Okay. And then we just want to call root dot left and sum and pre-order root dot right and sum. And so now I'm thinking that, where's that? Okay. So I'm actually thinking this isn't going to work. I think this needs to be after, because we want to, if root is not null, no, this is in the right, should be in the right spot. Yeah, okay. So I was thinking we might have to add it after, but that wouldn't make sense because we have to add it first and then check if the total sum, or if it doesn't have any more children, and add it to total sum. So that's how this works. The runtime is O of n because we have to run through all the nodes, and then the space is O of h for the height. Hopefully that video made sense. Hopefully you guys learned something, and if you did, smash that like button. I'm going to be posting more videos, 3 videos every week probably, and make sure you guys join that Slack or LeetCode competition, and I'll see you in the next video. Thanks for watching.